Hi to all. In this video, we will cover the concept of internal rate of return. So in the previous video, we have already covered the net present value. And now the internal rate of return has a very particular meaning because we can think about the internal rate of return. Let's first refresh or remember what the notion of um, the net present value is. We are assuming that the fundamental value of a project, which should be reflected in the initial investment, basically, uh, but the fundamental value of a project is equal to the present value of future cash flows. And if a project is correctly, fairly priced, then the initial investment will be equal to the fundamental value, which is the present value of future cash flows. Okay. Now, if we have this random uh, initial investment, this given initial investment, and this stream of cash flows, okay, the IRR, okay, to get the IRR, let's assume beforehand that the project is correctly priced. Hence, the initial investment is equal to the present value of future cash flows. Okay, let's accept that as a fact. Now we need to get our formulas to hold, or in other words, the initial investment should be equal to the present value of future cash flows. Let's see if that is the case. Okay, so let's keep this in mind. I think this is a great way of starting to think about the internal rate of return. Then I will give a couple of other remarks, of course. Okay, the project is correctly priced. This initial investment is the fundamental value of the project, and these are the cash flows. Let's see if that is true or not. If we take the long approach, we can discount each one of these cash flows by dividing by 1 plus the rate. We lock this rate. By now, I think everyone should be an expert to the power of time. We do not lock time. We do not lock the cash flow. We only lock the rate. And now we scroll to the right, and there we go. And now the present value of future cash flows is the sum of all this. And there is a problem. This is not holding. The present value of future cash flows is higher than the initial investment. So these two things do not match. Let's give it a try with Excel. Okay, so what is the present value of future cash flows? We can quickly do it. We can quickly calculate it with an Excel shortcut, which is NPV, which is not net present value. This is present value of an uneven stream of cash flows. We give the rate, comma, all these values. We close this. Yeah, so it seems we calculated the present value of future cash flows correctly, but this is not equal to the initial investment. Now, the internal rate of return, can we make this hold? Well, if we change the discount rate, we could make it hold. So if we increase the discount rate to 6%, now this present value of future cash flow starts decreasing. If we make it 6.5, it starts decreasing. If we make it 6.8, it continues decreasing. And so on, we can continue increasing the discount rate until the present value of future cash flows will match the initial investment. When we achieve that discount rate that we will get here, that will force this story to hold. So initial investment is equal to the present value of cash flows, that is then it is the internal rate of return. Now, rather than iterating multiple times here ourselves, and we're still not finding the correct rate, we can let Excel do that. So we can use data and then what if analysis goal seek, and we can, uh, okay, and of course we need to add one more thing, NPV. So NPV, if this story is holding, the initial investment is equal to the present value of cash flows. Let's keep in mind then NPV is the present value, the fundamental value of a project, or present value of future cash flows, minus the initial investment, because that initial investment is negative. I'm just adding. So of course, because these two things are not the same, NPV is not zero. When we achieve our goal to make these two things the same, NPV will become zero. As we continue increasing this rate, NPV is getting closer to our goal, which is zero. Rather than doing this ourselves, we can have Excel do it. What if analysis goal seek, and then we want to set this cell. When these initial investment is equal to the present value of future cash flows, then net present value will be zero. And we want Excel to make net present value zero by iterating as many values as possible, all possible values of the discount rate, until Excel finds one discount rate that makes initial investment equal to the present value of cash flows, and therefore net present value will be zero. We allow Excel to look for this, and we end up with this rate here, 8.09%. That is the internal rate of return. So the internal rate of return is such a rate that makes, let me see, yeah, I'm gonna make this bold, italics, and also underline and caps lock, makes the initial investment equal to the present value of future cash flows, so fairly priced investment. It makes that story hold. If that story is holding and initial investment is the same as present value of future cash flows, then at NPV is zero, right? Because NPV is present value of future cash flows minus initial investment. So IRR is such a rate that I'm going to copy this. It's going to be easier. That makes the net present value equal to zero. And we can think of the IRR as the holding period return of an investor, or YT, or yield to maturity, if the equivalent to a yield to maturity when in the framework of bonds. Okay, so we found it with the goal seek, but can we find this in an easier way? Yes, Excel has this formula which is IRR. And now you will think, well, this makes my life much easier. And it is just IRR. Then you select all of the cash flows, including the initial investment. And this is there is an important distinction here. When we were calculating NPV before, we did not include that initial investment. With IRR, we include all of the cash flows, including this first one, and then we close this. And as we can see, now I'm adding these shapes just to show these two things are exactly the same. We found this rate with goal seek through a long approach, and here we just found it using IRR command. Okay, and that's it. We have identified the internal rate of return. I hope this was helpful, and thank you for your attention.